In this lesson, we're going to look at how to calculate concentration using percent mass to mass, percent mass to volume, or percent volume to volume. So if we look back at a solution is a mixture of two or more substances that are in a single phase. So we have a solvent, which will dissolve a solute inside of that. So once those are mixed, those will create our solution. So the solution is made up of the solvent, which dissolves the solute. And so we can see here that the two different substances look like one single phase. And so if we were able to see at the atomic level, we would see that the water is surrounded by each of the ions of the solute. So concentration calculation, we have looked at molar concentration, which is a number of moles of solute divided by a volume of the solution. So all concentrations are looking at a quantity of solute divided by a quantity of solution. So molar concentration, which is N over V, or number of moles of solute over volume of solution, we've looked at. Today we're going to look at percent concentration, so using percent mass by mass, percent mass by volume, and percent volume by volume. And then if we have very low concentrations, we can calculate a parts per million, or parts per billion, or parts per trillion, and that we are not going to be doing right now. So percent concentration, this is when we have we're talking about an amount of solute dissolved in 100 parts of solution. So that 100 parts can be a mass or a volume, and we'll look at each of those scenarios. So we'll start with a percent mass by mass. So this is where we are talking about a mass in grams of solute per 100 grams of the solution. So remember, solution is total solute and solvent together. So to calculate that, the percent mass by mass would be the mass of the solute in grams divided by the mass of the solution in grams, and then multiply by 100. So example, we have a tube of toothpaste that has a concentration of sodium fluoride, which is 0.243%. And if that tube contains 75 grams of toothpaste, how much sodium fluoride is present? So the mass of sodium fluoride, or our solute, is the thing we don't know and we want to solve for. Our percent mass to mass we know is 0.243. And our total solution, so the toothpaste is the solution here, and the total amount of that we have is equal to 75 grams. So I'm going to take that formula that I have, so my percent concentration mass by mass is mass of the solute over mass of the solution, and then times 100. So I know my percent is 0.243. Mass of solute is what I don't know, and mass of solution is 75 grams. So to undo and isolate or solve for the mass of sodium fluoride, I have a division by 75. So to undo that division, I'm going to multiply by 75, and then I have a multiplication by 100. So to undo that, move it to the other side, I'm going to divide by 100. So that's going to leave me with the mass of solute, or sodium fluoride, on that side. And once I plug that in to calculate, the mass of sodium fluoride is 0.182 grams. So that is the solute. Okay, another example. So potassium chloride solution is made up of 4 grams of potassium chloride dissolved in 46 grams of water. So what's the concentration of this solution in a percent mass to mass? So I have the mass of my solute, or KCl, is 4 grams. My mass of solution, so I'm given my mass of solute, which is 4 grams, and my solvent is 46 grams. So the solution would be the two of those together. So 46 grams of water and 4 grams of potassium chloride gives me 50 grams of solution total. And I need to calculate the concentration in percent mass to mass. So I have my mass of solute divided by my mass of solution times 100. So that is 4 grams divided by 50 grams. And that is going to give us an 8%, 8% mass to mass concentration of potassium chloride in this solution. Okay, the next one we'll look at is a percent mass to volume. So here we're looking at a mass of solute per 100 mils of solution. So to calculate that, I'm going to take my mass of solute in grams and divide by the volume of solution in milliliters, and then multiply that to 100 to get to the per 100 mils. So when I just take my mass of solute and divide by my volume of solution, so in grams for solute and milliliters for solution, that is going to give me a mass per milliliter, and then by multiplying by 100, that will give me a mass per 100 milliliters. And the other thing is percent is just French for out of 100. So this is why we multiply by 100. Okay, so another example, an IV solution is prepared by dissolving 25 grams of glucose in water to make a 500 milliliter solution. What's the percent mass to volume of glucose in this IV solution? So we have the mass of glucose is 25 grams. We have the volume of solution is 500 mils. And my formula for concentration percent mass by volume is the mass of glucose in this case over my volume of solution and multiplied by 100. So I have 25 grams per 500 mils, and that is going to give me a 5% mass to volume concentration. Okay, another example, how many grams of sodium hydroxide do you need to measure out to prepare 2 liters of a 12% mass by volume concentration of sodium hydroxide solution? So what I know is my volume of solution is 2 liters. I need to convert that into milliliters, so that's 2,000 milliliters. My percent mass to volume is 12, and I need to find my mass of solute. So my percent mass to volume is equal to my mass of sodium hydroxide, or solute in this situation, over volume of my solution times 100. So I have, I'm not sure, the mass of sodium hydroxide, that's what I'm going to calculate. 2,000 milliliters is the volume of the solution, and 12% is my concentration. So, and I forgot the times 100. So this is a division by 2,000, so I'm going to multiply by 2,000 to move it over. Multiply by 100, I'm going to divide by 100 to move it over. So I have 12 times 2,000 divided by 100 is equal to the mass of sodium hydroxide. And once I calculate that, mass is equal to 240 grams of sodium hydroxide. So I would need to dissolve 240 grams of sodium hydroxide in 2 liters to create a 2 liter solution that is 12% mass by volume concentration. Okay, last one we're going to look at is a percent volume to volume. So this is a volume in mils of solute to 100 mils of solution. So I'm going to take my volume of solute in mils, divide by my volume of solution. That'll give me a per mil, and then I'm going to multiply by 100 to get to per 100 mils. So concentration of ethanol in a bottle of wine is 10.5% of volume to volume. Calculate the volume of ethanol in a 750 ml bottle. So I know my percent is 10.5. My volume of solution is 750 mils. And I'm looking for my volume of solute or ethanol here. So my percent volume is volume of my solute, ethanol in this case, per volume of solution times 100. So I'm not sure. Volume of solute, 750 mils for my solution, and my percent is 10.5. So this is a division, so I'm going to multiply by 750. That's multiplication, so I'm going to divide by 100. So I have 10.5 times 750 divided by 100. And that's going to equal my volume of ethanol. So 78.75 mils is my volume of ethanol in 750 mils of wine.